Welcome to two projects. In this video, we are going to explain the project Organ Matching and Transplantation. Before diving into the execution, let me give you an overview of the project. So, organ transplantation relies on accurate matching of donors and recipients, but traditional centralized systems have issues like data tampering, security risks, downtimes, and lack of transparency. So, this project uses blockchain technology to create a decentralized and secure system for managing hospital, donor, and patient information. Blockchain ensures data can't be tampered with, is always available, and is transparent to users. So, this system makes the organ matching process more reliable and trustworthy, helping to save more lives. Now we'll know about blockchain, how does it work and its advantages. So, blockchain is like a digital ledger that records transactions securely and transparently. Instead of having all the data in one place, blockchain stores records as blocks of data, each with a unique code called a hash. These blocks are distributed across multiple computers or nodes, making it much harder for anyone to tamper with the data or compromise the entire system. So, in this case, the blockchain stores data about hospitals, donors, and patients, including details such as donor organ availability and patient organ requests. So, blockchain offers several advantages. First, it is decentralized, meaning the data isn't stored in one place. Second, it enhances security because the data is stored in encrypted format that is very difficult to alter or hack. Third, it promotes transparency as all transactions are recorded and visible to authorized users. Fourth, it ensures data immutability, meaning once something is recorded in the blockchain, it can't be easily changed. Finally, it is resilient to failures because even if some nodes go down, others continue to maintain the data. So the data is always safe. And there are many types of blockchain like Bitcoin, Stellar, Ripple, Ethereum, etc. We are using Ethereum blockchain in this project. So Ethereum blockchain is a decentralized platform renowned for its support of smart contracts. So, smart contracts streamline the organ matching process, ensuring efficiency and reducing human error. And we are also integrating Ganache and MetaMask in this project. So, Ganache is a user friendly interface for monitoring Ethereum blockchain activities. It simplifies tracking of accounts, transactions, and smart contracts, making it accessible even for users without in depth blockchain expertise. Ganache offers detailed transaction information, including sender, receiver, amounts, gas usage, and success status, aiding debugging and ensuring transaction accuracy. It also tracks smart contract deployments, confirming correct deployment and functionality. So, this transparency simplifies monitoring and verification processes. And Ganache lets us dive into the details of each block on the Ethereum blockchain. We can find out when a particular block was added, what transactions took place within it, and how much computing power, that is gas, was used. And Ganache also enables data retrieval from stored blocks, allowing developers to access and analyze specific block information. Coming to MetaMask, MetaMask is both an Ethereum wallet and a browser extension. It simplifies cryptocurrency management and provides direct access to dApps, making interactions with blockchain applications easier. In this project, MetaMask ensures secure Ethereum transactions, promoting transparency by showing the deduction of ETH as fees. So, this transparency maintains accuracy and ensures confident, reliable financial interactions within the system. So, blockchain is integrated in this project for managing hospital, donor, and patient data securely and transparently. Using the Ethereum blockchain, information about organ availability and requests is stored in blocks with unique hashes, ensuring tamper proof records. The decentralized nature of Ethereum ensures data resilience, and smart contracts streamline tasks like donor recipient matching. Additionally, blocks in a blockchain are connected through hash functions, forming a chain where each block includes the hash of the previous one. So this linkage maintains the integrity of the entire blockchain because any change to a block's data alters its hash, affecting subsequent blocks. Overall, blockchain streamlines the organ transplantation process, making it secure, efficient, and trustworthy. So this is how we are using blockchain in this project. Overall, the project aims to make organ transplantation safer and more efficient. By using blockchain technology, we ensure data security, transparency, and reliability. So, this benefits patients, donors, hospitals, and healthcare providers, making the process smoother and more trustworthy. Ultimately, our goal is to save lives by improving organ matching and transplantation outcomes. So, this is about the project. Now we'll look at the software and hardware requirements to execute this project. Software requirements are Python IDE of 3.7.0 version, Node.js, Visual Studio Community version, Ganache, and MetaMask Chrome extension. Backend languages used are Python, JavaScript, and Solidity. Framework used is Django. Frontend languages used are HTML, CSS, JS, and Bootstrap 4. And hardware requirements are processor of i5 and above, RAM of 8 GB and above, and ROM of 20 GB and above. So these are the requirements. Now we'll see the execution. Before execution, first we need to open the code folder, which contains the project source code files. So this is the code folder and these are the contents I have in the code folder. This is organ folder. Inside this folder are Python code files that are intended to be dynamically loaded into the project during runtime. This is organ app folder. So this folder comprises a static folder which contains files related to CSS, JavaScript, and Bootstrap. These files contribute to the visual and interactive aspects of the application. And organ app folder also contains a templates folder. Within this folder, we'll find all the HTML pages used throughout the project. It includes pages like index.html, home.html, and more, representing various sections of the website. And it also contains Python code files that will be executed during the runtime of the application, supporting its functionality. This is manage.py file. So it is a command line utility that comes with Django. It provides various commands for managing Django projects, including tasks like running the development server, creating database tables, applying migrations, and more. This is organ SOL file. So this file consists of Solidity code. It handles data structures, functions, and events with modifiers for validation. This is IPFS run.bat file. So this run.bat file is used to start IPFS server. IPFS is a decentralized file storage system for secure and distributed data sharing. Blockchain is effective for recording transactional data, but for large file storage, it integrates with this IPFS, short for Interplanetary File System. So large files like images, documents will be stored in IPFS. And this is run.bat file to start the application. So instead of executing the program through command line interface, we have created these Windows batch files to execute the project. Before running these batch files, first we need to host the Ganache server. Open Ganache. I have already created a workspace. Click on it. So we can see I have hosted the Ganache server. Now double click on Start IPFS BAT file. So the IPFS server has been hosted. Minimize this. Now double click on the run.bat file so that the manage.py file is compiled. So here the Django framework will host the application locally at the default address localhost and port unless configured differently. This is the local host and this is the port. Now copy the local link provided by the framework. I'm copying it and paste it into any web browser. I usually prefer Google Chrome. After pasting it, type index.html at the end and hit the enter button. So the home page of the project has been displayed in the browser. This is the front end built using Django framework. So here we can see hospital login, donor login, user login, and new hospital sign up links. So if you are new to the system, we have to register ourselves first. So we'll register as a new hospital. Click on new hospital link. We have to fill in these details. Username would be Ram. Give the password. Give the contact number. Give the email ID. Give the address and the hospital name. I'm giving it as Gandhi Hospital. Now click on register button. So here we can see sign up process completed. All these hospital details will be stored in blockchain in a form of block. We can see that in Ganesh. So we can see a new block has been created, block number 5, in which all these hospital details which we have just entered will be stored. So we can see the date and time at which the block has been created. So at this time, on this date, these details have been stored. And here we can see the gas used for this transaction. Now minimize this. So we have registered the hospital. Now we'll log in as hospital. Click on hospital login link. Give the credentials of hospital. Username is Ram. Give the password and click on login button. So we have logged in as Dr. Ram. And here we can see add patient history, add donor history, match organs, view transplantation and logout links. Click on add patient history link. So here hospital can add patient history for organ requests. We have to fill in these details. Patient name would be Ramesh. We have to give the address, contact number, disease history. I'm giving it as chronic kidney disease, need transplant of size 3 by 3. So this is the disease history I have given. Required organs is kidney. Now we have to give the Aadhaar number. And after filling in all these details, click on submit button. So we can see the patient details are added with ID. So this ID can be used by patients to track organ matching status. So in this way, we can add any number of patients who need organs. We have to fill in these details and click on submit button to add patient's history. So all these patient details will also be saved to blockchain. We can see that in Ganesh. So we can see a new block has been created, block number 6. We can see the date and time at which the block has been created. We can see the gas used for this transaction. So we can retrieve the data from here. We can retrieve the stored data, that is the patient's data, from here. Minimize this. Now click on Add Donor History link. So here hospitals can add the details of donors who are interested to donate. So donor name would be Suresh, address, give the contact number, give the donor health condition. I'm giving it as very healthy. Interested in donating, blood group is O positive. Donating organs. So this person wants to donate kidney. Now we have to give the Aadhaar number. We have to upload the donor image here so that patients and doctors can know about their health condition. They can view the picture and they can know the health condition of this donor. So click on choose file. I'm selecting this picture. Click on open. So after filling in all these details, click on submit button. Here we can see the donor details with ID have been added to the system. So ID can be used by the donor to track organ matching status. So in this way, we can add any number of donors who are interested in donating. All these donor details will also be saved to blockchain. We can see that in Ganache, a new block has been created, block number 7, in which all these donor details will be stored. We can see the date and time at which the block has been created, the details have been stored. We can see the gas used. So this much gas has been used for storing this data. Minimize this. Now click on match organs link. So here hospitals can view patients who need organs. So we can see all the patient details, patient ID, patient name, contact details, disease history, organs they're requesting for, and other details. So we have only one patient registered. We have only one patient requesting for organs. If we have any other patients requesting for organs, their details will also be displayed here. And we can see a click here to match organs link. By clicking on it, we can see the list of donors and select the desired donor. So I'm clicking on this link. So we can see I have one record here. So we can see the donor details, donor ID, donor name, contact details, his health condition, organs he is donating, and other details. We can see the image of the donor. We have only one donor registered. If we have any other donors who are interested to donate, we can see their details also here. And we can see it is a match. So this donor is also interested in donating kidney, and the patient is also requesting for kidney donation. So this is a match. And here we can see a send alert link. By clicking on this link, a alert message will be sent to both the users, donor, and the patient about the match. So I'm clicking on this link. So here we can see the alert message has been sent to the patient and the donor. Now click on view transplantation link. So all these details will be stored in Ganache. We can see that here blocks are being created. So in this block, these match details are being stored. We can see the date and time at which the block has been created, at which the details are being stored. We can see the gas used for this transaction. Minimize this. And in my MetaMask wallet, click on the Chrome extension. So here we have to give the password. So we can see I have a balance of 99.9939 ETH in my MetaMask wallet, which represents the deducted amount after recent transactions. In the context of blockchain, transactions refer to the actions that are recorded on the blockchain ledger. We have created an account, we have registered a patient, that is a transaction. So this is my ETH balance. Now, by clicking on this view transplantation link, here we can view all the matches. So we can see all the details of the patient, patient ID, patient name, contact details, disease history, organs they're requesting for, and other details. So in this last column, hospital can see which donor organ has been matched or which donor organ has been assigned to this patient. So we can see donor Suresh's organ has been matched with Ramesh. Now click on logout. Now we'll log in as donor. Click on the donor login link. Here we have to give the donor ID, that is Suresh1. Now click on login button. So we can see we have logged in as Suresh. Here we can see view donate status and logout links. Click on view donate status link. So here donor can see which patient is matched with his organ. So we can see the donor details and we can see the match status. So Suresh's kidney has been matched with patient Ramesh. Now click on logout. Now we'll log in as user. Click on user login link. Here we have to give the patient ID, that is Ramesh1. Now click on login button. We have logged in as Ramesh. Here we can see view organ request status link. Click on it. So here patient can see which donor is matched with his organ. So Ramesh has requested for organ kidney. Donor Suresh's kidney has been matched. We can see that here. Now click on logout. So in Ganache, we can see the blocks created for every transaction details, for every registration details. To store these details, a block has been created. So we can retrieve the data from here. I'm clicking on this block. So here we can see the block hash, the transaction hash. I'm clicking on the transaction hash. Here we can see sender address to contract address, gas used. This is the gas used till now. The gas price, gas limit, mined in block 18. So we have created 18 blocks and we can see the transaction data. Minimize this and in my MetaMask wallet, so we can see the ETH balance remains unchanged after each block creation because the project's actions don't involve significant ETH transfers. This is normal as not all operations lead to substantial balance changes. So in this project, we have registered a hospital. So hospital can add patients who are requesting for organs and can add donors who are interested in donating. And we can match the patient and donors according to their requirements and send alert messages to both of them about the match. So this is what we have done in this project. So in this project, we have utilized blockchain technology to manage organ transplantation data securely and transparently. By implementing Ethereum based smart contracts, We ensured data integrity, enhanced transparency, and streamlined the organ matching process, ultimately improving efficiency and trust in the system and saving more lives.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.